All right, today we're going small. I mean, really small. So small that the very rules of science kind of start to bend. We're talking about nanotechnology, this absolutely revolutionary field that's building our future literally one atom at a time. And that brings us to the big question.
Just think about that for a second. What if, instead of carving things out of big chunks of material, we could place every single atom exactly where we wanted it? That right there? That's the incredible, world-changing promise of nanotechnology.
So what are we actually talking about here? Well, the official definition is manipulating matter at the nanoscale, where everything is measured in nanometers. And a nanometer is 1/1000th of a meter. But here's the key thing you gotta remember. This isn't just about shrinking stuff down. Oh no. At this scale, we're entering a whole new realm of science where the normal rules, they just don't apply anymore.
Okay, to really get a handle on just how tiny a nanometer is, let's try to put it in perspective. You see a single human hair? That's about 80,000 nanometers wide. Now think about a strand of your own DNA. That's just 2 nanometers across. We are literally operating on a scale that's almost impossible to even imagine, right down at the fundamental building blocks of life itself. And you know what's crazy? This idea isn't even new. Way back in 1959, the legendary physicist Richard Feynman gave this talk where he basically dreamed up the whole concept of manipulating individual atoms. He famously said, "There's plenty of room at the bottom." And with that, he planted the seed for this entire field, decades before we even had the tools to make it happen.
So this is the most important takeaway, right? It's not just about making things smaller. When you get down to the nanoscale, this weird and wonderful world of quantum physics just takes over. Suddenly, materials can behave in totally new ways. They can get stronger, become better conductors of electricity, or way more reactive. Gold, for instance, isn't always gold-colored at this scale. It can actually look red. And that change in properties, well, that's the secret sauce of nanotechnology.
So how do scientists actually make this stuff? Well, there are basically 2 main ways of doing it. You've got the top-down approach, which is kind of like being a sculptor. You start with a big block of material and just carve away what you don't need. But then there's the bottom-up approach, which is really the holy grail here. That's more like building with Legos at the atomic level, assembling everything, piece by piece, exactly how you want it.
Okay, so that's the science behind it. Pretty cool, right? But the real question is, how is all this rewriting the rules of our world right now, today? First off, let's be clear, this isn't some far-off sci-fi concept. It's already here and it's transforming huge industries. I mean, its impact is being felt everywhere, from electronics to energy, but the single biggest area pushing this forward right now, it's healthcare by a long shot.
And in medicine, this is a total game changer for how we fight disease. Think about it. We can now engineer nanoparticles to deliver chemo drugs directly to cancer cells, which means they can attack the tumor while leaving healthy cells alone. Or we can use these tiny things called quantum dots that literally light up tumors for surgeons, giving them incredible precision. And get this, nanosensors could detect the chemical signs of disease in your blood long before you ever feel a single symptom.
It's also powering the very device you're probably watching this on right now. These tiny, hollow cylinders made of carbon, called nanotubes, they're starting to replace silicon to make computer chips that are way faster and more efficient. And then there's graphene, a material that's just a single atom thick, but is literally stronger than steel. That's what's making things like flexible, foldable phones a reality.
But okay, beyond our gadgets and our health, nanotech is also being used to tackle some of the biggest challenges facing humanity. Seriously, it's helping make solar panels more efficient so they can capture more sunlight. We're using iron nanoparticles that can literally break down nasty industrial pollutants in our groundwater. And we're building advanced filters out of carbon nanotubes that can purify water or even pull CO2 right out of the air.
The stuff that's happening right now is already pretty mind-blowing. But the truth is, we are just getting started. We're standing on the edge of the nano frontier. So, what's next? And maybe just as important, what are the risks we need to watch out for?
First, let's just follow the money for a second. The global market for nanotechnology isn't just growing, it's exploding. We're talking about going from just under $4 billion in 2022 to a projected $37 billion by 2030. That is a staggering rate of growth, and it shows you just how much industry and investors are betting on this technology.
But, with that kind of power comes some really big questions. The flip side is that the very same properties that make these nanoparticles so useful also raise some serious concerns. We don't really know for sure what their long-term effects on our bodies or the environment are. Could they build up in the food chain? And what are the ethics here?
Who gets access to this stuff? These are huge questions we have to figure out as we push forward. All right, now let's talk about what's just over the horizon. This is where things start to sound like straight-up science fiction, but I promise you, people are actively working on this stuff. Think about nanorobots that could perform surgery inside a single cell, or using AI to design brand new materials that have the exact properties we want. We're even talking about manufacturing where products could literally build themselves, molecule by molecule.
And all of this brings us to the final and most crucial point. We are gaining the power to engineer our world at the most fundamental level possible. We can literally rebuild it, atom by atom. So the question really isn't if we can do it anymore. The question is, how will we choose to build it? The responsibility is just immense, and that future, it's ours to create.